Ahmedabad. Are you familiar with this term, antenna engineering? Yes or no? Those who are in the third sem or fourth sem, can you raise your hand? You were the first sem? First sem? Second semester? Anyone in the fourth semester, third semester? No. Okay. No, hardly matters. It does not work. The complete video, then you have to start in a fixed place. No. I so both should be covered simultaneously. But you should not raise the stage. I will take one video. Okay, so I'll take it. See it. So it's fine. I'm going to start. Okay. Have you seen antenna? Have you seen antenna? Yes. Have you seen this type of antenna? So one to send signal to sky, that is the satellite, and another to receive signal from satellite. So most of the technology and technological parts are discussed in the morning session. It might be more technical, so I don't know to what extent you could understand, because it is the very advanced technology is associated with this. So you all are budding engineers, you all are students. But do you want to be students forever, the rest of your life? No, you'll have to be engineer. So my talk is for those who will be engineers in the future, but it is not really for only for those will be only antenna engineers. It is for all of you. Have you seen this type of antenna structure? That means you are exposed to antenna technology so extensively, and dimensions and geometry are quite different. Probably you or your previous generation, you have seen this antenna, it was for television. Are you familiar with this type of antenna? That means you know all this, all antennas you know. This is for radar. When you are flying, that is to be tracked by radar. And another one, it is very commonly seen in the cities for telecommunication purpose. So you know all these antennas, but do you know? I'm asking this question to antenna. When was it born? Is it lasting for last 10,000 years? No. 1,000 years? No. This technology is very young. So that you can correlate. So I'm giving, do you know these two great sons of India? Do you know? Both of them. Do you know their birth year? You reduce the volume. Volume. Do you know what they? Here is one more Narendra. That Narendra is from Bengal. Narendranath Datta, Swami Vivekananda. And the other one, Subhash Chandra Bose, Netaji. So antenna was born in between these two great sons of India, they were born. That's why you can easily connect. That antenna is not too old. That means in between these two. When? That is the first antenna. 1887. And you can see this antenna whenever you are going to Munich. Have you heard this name of the city Munich in Germany? The world's largest museum, science and engineering museum, is called Deutsches Museum. There you can see the first antenna. But the person who discovered it, first designed it, was one German. Heinrich Hertz. This is the year of this birth, but its birthplace is very interesting. So that's why I had to travel to Germany only to see the place of birth of antenna. It is in Karlsruhe. The upper floor was Hertz laboratory, and in this laboratory this antenna was first experimented. Are you familiar with the term dipole antenna or dipole? Yes or no? You know that. So this is the first dipole, this word. And this is the first experimental setup by which antenna was tested or experimented. Can you guess this structure, this picture? It is on a coin recently published in Germany on the occasion of 125 years of discovery of antenna. And this diagram is the near field pattern from a dipole that was predicted without weighing any mathematical things by Heinrich Hertz himself. So that's why on the coin they have printed the pattern of Hertz. So do you believe that Hertz in 1887, 1888, without knowing anything, the first planner or designer of antenna, he could successfully predict that type of near field radiation from one antenna? You can, you cannot. But see the insight of a person. He's a person like you, having the similar ability. Single head, two eyes, two hands, two legs. So using modern simulator, when you simulate it, you see exactly the same pattern you can produce, or it is produced. So you are so accurate in predicting the pattern. Question is, when this type of dipole starts radiating, how do they look like, the radiations? You can visualize. What does it indicate? It is the dancing. Dancing means it is resonating, right? So do you believe? Okay, so before going to that part, I'm showing you from Hertz the only book he wrote before his death. He did his work in 1887 and he died in 1894, 1st of January. That was his experimental work, and by which he determined the resonant frequency and established that it is resonator, it is a resonant circuit. Remember, it is 1887. We had no experimental instrument or measuring instrument equipment to do this measurement. I'm not going to describe the type of measurements he do or he did. It is unbelievably difficult type of experiments he had to do that time. This is the typical dipole. It's difficult for them to understand. Anyway, is there any of your teachers you are teaching in your class antenna? Probably many of you are here. Anyway, it's a very rare kind of information. You won't get any textbook or any reference book. Do you believe that this two straight dipole, a straight wire, is equivalent to one LC resonator? Just you go through. You understand this resonant frequencies like this? You know about this? Do you know? We want to make that resonant frequency very high. That means omega should be high. What does it indicate? Actually, many functions are not working. There is some problem in it for him also. Anyway, leave it. When omega is very high, your L and C should be low. So low C means, you know, C means capacitance. It is epsilon A by D. So when C is low, A should be very small, area should be small, and D is very high. That means circuit is going like this. So one part is done. I'm going to at this step. Now, we need to reduce the value of inductance. How to do it? It is expressed by this term, the number of terms. Not filing data. But what you are getting a better expression is another expression. So when you are trying to reduce the value of A, there is no need of any A. So you need to solve this balance. So ultimately, you are leading to this direction. That means I want to make it more efficient. Make it straight. Right? It's equivalent to just one straight line. And you want anything like that. So how do you extend it? The current, it is in terms of current. The current function of time, so it is the dancing current of time varying current, not by harmonic. And the other side, the circuit, because this is an incomplete circuit from your side, current has to be continuous. So to make the circuit complete, we have to invite another thing that is called displacement vector or displacement current. Probably you are not familiar with this. Just keep in your mind, during the course of time, it will be taught the displacement of line. That's why then it's a device in the circuit, electrical circuit, which is treated from both angles simultaneously. One from circuit theory, another from field theory. And it is the only class of engineer, the antenna engineers, they have to be very focused to handle zeros together. Otherwise, you cannot design correctly. This is one practical diagram. 40 minutes long ago. This is one practical diagram. This is one practical diagram. But you know, experiment we made it was antenna. Now we use it, but we did not care about this because we did not know how to use it. What was the first practical antenna on this earth? Dipole was not the first antenna, but first practical antenna. This is the first practical antenna that started. Actually, Marconi started to build this antenna in 1897 and finally one first experiment was. Can you guess the structure of this antenna? Do you think that these four masts are antennas? It is not dipole. This is not antenna. This is the better picture. It is the multi-strand. These four towers, the golden. This is the antenna itself. It's a coil. So that antenna can withstand therefore side of Atlantic. Because if you look at this communication link and communication path, one side of right side is England, Portugal. In Atlantic, 3,500 kilometer path across. The left side is the border of Canada, Newfoundland. The distance now, the modern flight it takes more than 6 hours to cross the distance. In 1901, Marconi was the first one to communicate using no wires wirelessly across the distance. How? By properly designing and executing engineering of and analysis is taught. Analysis is taught in undergraduate. But I'm not going to tell you very detail. How to analyze it mathematically? Because when you're designing some antenna, you need to analyze it. Right? This is like this type of wall or building is made by bricks. So when you are going to analyze it, you don't need to analyze the entire structure. Analyze it by small element we call artificial diagonal or small element. So define what should be the length, what should be the diagonal. That means practical thing is much bigger than this elementary thing which we generally analyze for the first time. I kept something for analysis because the purpose of analysis is to find either electric field or magnetic field or both. And friends, electromagnetic is probably the easiest topic of all that is taught in your 4-year course because we have to deal with only two parameters. And they are very obedient and rule following to elements. There are some very basic rules. There are some boundary conditions. So with this boundary, if you can set the proper boundary condition, your life is very easy to find your thing or solve any problem. There is no other You are concentrated on this because this part A has been required to save your life, but that A plays very so mathematical part plays very interesting role in this analysis. So I am not going to pardon it. Not to very so speaking of this part. Yes, so this is one thing that I'm telling you that whenever you deal with any kind of antenna, the very fundamental science you need to know either practical dipole or 3-3 dipole. And surrounding this dipole, there is magnetic. That dynamics you already have seen. Electric fields are moving like this. But when you are far off from the antenna, the radiation which is in the form of electric and magnetic field, they are very linearly polarized. In today's morning talk, Dr. Rao explained you that the polarization is a very important part of your antenna design. So here electric field is vertically polarized, so that's why you see the electric field is going vertical. But I already mentioned about arch and this guy. Immediately after that, we got from harmonic. It is called monopole antenna. Nowadays, you know about now. The contemporary, another antenna was conceived and tested on Indian soil. Can you hear? What is that? Who is the person? This is the first horn antenna that we got in 1894. That is the end of 19th century. And this antenna was designed, devised in the city of Indian capital. So, about a century ago, more than a century ago, the electronics engineers got 3 major types of antennas. You probably know about the success of antenna engineering. The 1901, the Nobel Prize in Physics was given to wireless connectivity. And at the same time, because I'm just showing you the chronology of development of technology, because the time was not very good for the entire world. First World War started. Okay. Two world wars. Later on, you can understand. At time, but development of technology, both like that. So you got many new things during it, or immediately after each war. And nowadays, you are encouraged by some of your professors that you will be missile engineer. Mind that you will do again war. What's that? Evolution. The antenna also going to this kind of evolution. You see, just after the war was over, Again, that would give to us a different form. 1926, the next year, is going to be celebrated its centenary. It's called year-round antenna. Antenna engineers very much care about this valued antenna. It's very beautiful antenna which we always use it for our technical purpose. So it is in Japan. The other one we got 1933, that is the dipole. Carl Yancey, father of radio astronomy. This is the antenna in Aero-Space. Yes, the caption is written over there. 2.5 megahertz signal from the galaxy. That is the first radio astronomical signal that signals, radio signals that are coming from outside. So it is not only that an optical signal or just by optics we see the outer world, outer space. Now, the new window was explored and it was established that the radio signal is giving you a message of outer space or outer galaxy. And definition is enough. I can start right now. 1937. In my bag. Oh no, it's never. So I'm touched on my bag. So it is never. We have seen these large reflectors. Large reflectors are first used for radio astronomical purposes in 1937. But that is not true. It was applied, but reflection is possible in case of antenna engineering. If you look at here, I got it from historical archive. Hard set means reported multiple reflectors. Look at the reflectors used in it. So the concept of optics, concept of reflector is there. Nowadays we are using reflector reflectors. Even in our residence we are using Pakistan, Airtel. So we got the test of using this 1947. That is very interesting. We always claim that J.C. Bose is the father of Indian radio science. He discovered on his own way, discovered but really if you go modern art is basically built based on the extensive theoretical work that we did. After downloading, because it's just one slide, but different slide have to spend hours and hours and read everything. Okay. So all the things we do is based on this paper. Okay. But the idea came from this book. The complete analysis. So antenna engineering is not as by a single day. It's not chronology and very systematic, very passionate, very follow efforts by scientists. You don't do that in 50 years. India also took part, Germany took part, scientists from different parts of Japan took part. So, kind of the entire community of engineering is there. So, it's better to stop because already I got on the alarm. Another phase of development, of technology. You don't have showing you a few technologies. What about it gave us different types of and for your curiosity, Or the satellites. What you know about the you know, elevated and command see when it is fired continuously monitored. How? Using this type of method. That is called telemetry. Then just after calling or software or broadband. So future ability is more limited with antenna technology. It's called fire. Again, particularly I'm not going to discuss. 1952, we got printed something. Now, present-day world. Two types of antennas are actually working extensively. One in the morning, large reflectors on and on. Like power signal to send to US. He also made about medium wave antenna, low wave antenna, something like that. That's what is completely covered by the technology got in 1950. It's called printed circuit. So my next part of this talk was about printed circuit. Anyway, sometime thank you. Yeah, that's
if anyone have any queries, you can ask.
on your side. Question on your side.
Any queries?
Intelligent IRS or economical intelligence?
So is it concentrated on PCP or
Do you make your question public because other people they cannot hear you? Because they will ask that what intelligence service what they want.
Reconfigurable intelligence services, which are enabling technology, which called 60 technology. So I want to ask whether that is made on printed circuit board using metamaterial services or what's.
Her question is not on antenna, make it clear. Kind of emphasis or intelligent service or intelligent service. Intelligent and confident both. Anyway, so no, it cannot be because if it is mechanical scalable, then it has to be its own dynamics. But if you keep it very straightforward and switch away electronics and electronics switch to things. So there are two ways. Normally we don't use kind of adaptive optics or microcontroller optics. Sometimes it is so. So far, all surveys in the switches or the question is what type of materials you want to. They're waiting for the next talk.
One more question, sir. Sir, one more question.
Please.
Right.
Start your question.
You have collected so many documents. From where did you collected this documents? From where did you collect this information?
Yes. No, I'm asking you to
I wanted to learn this address. How can I learn? From where can I correct all this? Yes.
Okay, I can talk to you. He's going to start. But for learning, actually, for learning, any part of the body, anywhere you have only one option. You have to read and reading materials, that is important. But passionate, you need to give you everything.
Thank you so much, sir. Good afternoon. Our new guest, Professor Rawat Pujara, sir, is a renowned expert in microwave and antenna engineering. He serves as a professor and head of electronics and communication in Nirma University, Ahmedabad. Okay, let us welcome him with a big round of applause for today.
Very good afternoon, all of you. Thank you so much for inviting me to this wonderful campus. Friends, this is exactly 3 o'clock. And I will be with you for next 45 minutes exactly. I have been told like this. Fine. So we'll start with a few fundamental questions. And based on what you listened since morning, you need to answer. Okay? So my lecture will be very simple. We'll have question answer based on whatever you have learned since morning. We'll try to revisit. First question. What is antenna? Come on. Wonderful audience. I think I have not seen such a bright audience in my career of last 29 years. This is what I tell in every workshop. Come on, friends. What is antenna? You will reply. Yes? Yes? That? Come, yeah. Yes, sir. Go ahead. Signal receiver. Oh, very good, very good. Fine. So let me tell you, the word antenna came from a word antennae, a sensory appendage found on the head of insects. On the screen you can see two pictures. One is a butterfly. Okay. And you can see this is basically a sensory object found on fishes or maybe butterfly. So this helps butterfly or fish to sense their surrounding, to detect smell. So in that sense, antenna is also a sensor. Italian inventor Marconi, Professor Poha, gave a very nice history of antennas. So Marconi was an Italian scientist. He used this word antenna for his invention, describing a long wire, and that he used as an antenna. Now my next question, what does antenna do? So first thing that you came to know today, antenna is kind of a sensor. Okay, now what does it do? What is the function of an antenna? Yes? Do you get an antenna with you? Most of you carry a cell phone with you, or you have seen television, cell phone. All these are examples of wireless communication, satellite communication, radar communication. You have heard of Wi-Fi, Bluetooth. So in your laptop also there is an antenna. In your mobile also there is an antenna. Okay. So now can you tell me what is one simple function of an antenna? What does it do? Transmit and receive what? Which type of signals? So it transmits or receives electromagnetic waves. Okay. So I will now formally define antenna can be a metallic wire or a rod or a slot capable of radiating or receiving, meaning transmitting electromagnetic waves or receiving electromagnetic waves. This is clear. Later on, we'll see there are directional antennas. We want antenna that can direct energy in a specific direction, given direction. This is a very general definition. Anything, maybe a wire, maybe a rod, maybe a slot, maybe a patch antenna, helical antenna. You have heard of reflector antenna, Hall antenna. These are all capable of radiating and receiving electromagnetic wave. My third question. I'm going to take your exam at the end, so please remember whatever you learned today in this 45 minutes class. My third question. What is the importance of antennas in modern world? Can you survive without antennas? Do you see applications of antennas around you, surrounding environment? Do you see antennas? What is the importance of antennas? Can you tell me in one line? Importance of antennas in just one line. Huh? Communication. A specific type of communication. In your study, you have wired communication and wireless communication. I'm talking about wireless communication. So, friends, wireless communication is impossible without a pair of antennas, which is a transmitting antenna and a receiving antenna. This is clear. Now you think of applications of wireless communication. Do you see wireless communication? Can you give me examples of wireless communication that you have seen so far? Mobile communication. Very bright. Awesome. Wonderful batch of students. So what is mobile communication? Any other applications, examples? Huh?
Wi-Fi,
Speak loudly.
Bluetooth, Wi-Fi.
Bluetooth. Very good. What are the other examples of wireless communication? Wi-Fi. Very good. So I have listed at least 10 different applications of antennas. Antennas you can see in mobile communication. I don't know you have seen these kind of device. Perhaps the initial days Nokia mobile, so that has an antenna outside. These days in your mobile phone you have FIFA or what we call patch antenna, microstrip antenna, which Professor Guha was trying to tell at the end of this session. Printed antennas. So these antennas are part of your cellular phone, mobile communication. You have television reception. Of course, these days you receive television signals through cables also or fibers also. But you might have seen these kind of disc antennas, which we call parabolic reflector antennas. So these are all examples of wireless communication. This is another interesting example, radio telescope. So do you know what is the application of radio telescope? Radio telescope. Any guess? You can see the diameter of an antenna, 110 meter diameter. Just imagine. See antenna, microwave, electromagnetic. You need to visualize. You need to imagine. Now think of this glass. What may be the length of this glass in meter? Maybe a few meters. Correct? Maybe 7, 8, 10 meters. Now you think of this antenna, 110 meter diameter. What may be the use of this kind of radio telescope? Any guess? Satellite communication. What you are talking about is for Earth station antenna. Now this is for studying the radiation that comes from different planets. Okay? So for that, we use this antenna. Now I have a question for you. See the diameter of this antenna, 110 meter diameter. Whereas all your mobile antennas, they are very small. Why? If you are given a task to design an antenna, you will select a big antenna or a small antenna. small antenna. Why? The reason is we like our devices to be very, very compact, thin, lightweight. So that is the only criteria. But there is another criteria also. How do you decide the dimension, the configuration of an antenna? That depends on what? Only compactness. So there are many parameters that decide the configuration that you will be selecting. So one among them is how far you want to go. In general, if you have an efficient antenna, I define what is efficient antenna. Bigger the antenna, it will give you more gain. You have more gain, you can travel. Very, very simple. So if you want to now go for radio telescope, which is far distance, you need more gain. Whereas in mobile communication, you might have studied somewhere in your wireless communication course, you have cell structure. You have the mobile cell structure. So hexagonal cells are in this city only. Okay, so you are traveling lesser distance. Okay, so that is also a parameter. Frequency is also a parameter. I'll discuss more about all these if time permits. This is again an example of radio telescope. This is antenna as a sensor. There is something called radiometer. I don't know how many of you know India. You should take proud of for our ISRO, Indian Space Research Organization. Yes or no? So, friends, ISRO has its space program for satellite communication, for navigation, for remote sensing. So, this is an example of remote sensing. Remotely, when your television you use remote to control the functions of your television. Similarly, to study from a far distance, we have a radiometer, which is a kind of a payload or a satellite that will sense from Earth. You can see here, there is a cloud. So you can predict monsoon, you can predict earthquake. Okay, so for that there are dedicated satellites. Fine. So many applications. In your laptop also you have an antenna. Okay, you have antenna for radar also, biomedical applications also, ship to ship communication also. So far we have discussed 3 to 4 questions. What is antenna? What does it do? Function of an antenna? What are the applications of antenna? What is the importance of antenna in modern world for wireless communication? Can we survive without wireless communication? No, sir. Jigar ka tukda mobile phone will not work without antennas. So this is the importance of antennas in modern world. Now, friends, some of you are going to enroll for a course on antennas, maybe in your 3rd, 5th semester, 6th semester. So today I will give you a few basic types of antennas. So number 1 is wire antennas. If you have paid attention to Professor Duha's class, he discussed about dipole antenna. He used the word dipole, monopole. So these are all wire antennas. Now I have a question for you. Morning, Rao sir talked about reflector antennas. Duha sir used the word dipole antenna. So which one you will be using for a long distance communication? A wire antenna or a reflector antenna? For example, ground station, satellite communication, radar. You will use a wire or a reflector. Why? You require more gain. And I will give you a simple rule. If your efficient radiator, efficient antenna, bigger antenna will give you more gain. So whenever you have more gain requirement, you should go for bigger aperture, bigger antenna. Now, after your BTech, if you join ISRO, you will be given a task to design an antenna. So what you should ask to your supervisor, to your boss, if he will say, go and design an antenna, Immediately you should not run. You should ask for which application. Correct? Because depending upon applications, you will have gain requirement. Depending upon gain requirement, you will decide the configuration. Another important parameter is frequency. Which frequency do you want to operate? Okay, so generally for antennas, starting from medium frequency up to high frequency, which we call gigahertz, and now terahertz. Tera is 10 raised to 10 raised to how many? 12. Giga is 10 raised to 9. So we use frequency in the range of gigahertz for satellite communication, radar communication. You should have all these questions now in your mind. Why you should use high frequency? Why not low frequency? Because I tell you, designing microwave circuit, microwave component, antenna at low frequency, medium frequency is relatively easier. The moment you go for higher frequencies, gigahertz, terahertz, the antenna design becomes difficult. Do you know why? Do you know why? Because many antennas, their dimensions are dependent on the wavelength. Now you tell me, if I have very high frequencies, very high, let's say 10 gigahertz, 10 gigahertz is how much? 10 into 10 is to 9. So can we say 10 is to 10? 10 is to 10 gigahertz. So wavelength will be smaller compared to kilohertz. The wavelength will be smaller. Okay, so when you go for very high frequencies, your antenna dimensions becomes smaller. Okay, now I'll give you a small piece for your mobile. For your mobile, do you know which frequency are you using for 4G, 5G, and now 6G? Can I use 10 kilohertz? Can I use 10 kilohertz for mobile communication? Do you know which frequency are we using for mobile communication? 5G, 6G. You all are students of ECE, electronics and telecommunication. Yes or no? Now you should have all these questions. So ask questions to yourself. Discuss about these kind of questions. If I use low frequency, the wavelength will be high and antenna dimensions will be very, very big. Can you carry a big antenna with your small iPhone or sensing phone? No. So that is one of the reasons. So frequency of operation also plays very important role. Configuration also plays very important role. Gain of an antenna, very important. Application, very important. So aperture antennas, Sir talked about Sir Jagdish Chandra Bose. We all should take proud. पहला proud क्या बोला था? एक इसरो के लिए proud. Second is Jagdish Chandra Bose. So he developed horn antenna and it was patented in US. And there are documents which says that the horn or the antenna developed by Sir Jagdish Chandra Bose were used by Marconi also. So there are documents. So we should have proud of Indian scientists. He worked here in Canada. So that falls under aperture antennas. Microstrip antenna, what we call printed antenna, planar antennas. Then comes array. When one antenna is not sufficient, you put so many antennas in a particular fashion, and that will give you more gain. Very simple words I am trying to explain. Then reflector antennas. There are many types of reflector antennas. If you pay attention to the morning class of Dr. Rao, he talked about parabolic reflector antenna, offset reflector antenna, inverse reflector antenna, lens antennas. So these are general types of antennas. On each type, you can have a book of at least 300 to 400 pages. And microstrip antenna, maybe you will find hundreds of research papers. Here I would like to take a minute. In your institute, IEEE branch, we have inaugurated, APS. Now APS comes out with magazine. I'm not talking about APS data or transactions. You all BTech student should try to understand, read at least one article from APS magazine. You will come to know what are the recent trends. With the support of, with the help of your teachers, faculty, at least one article from Antenna Propagation magazine, which I believe you will be able to understand and appreciate. So, these are the pictures of different antennas, wire antenna, aperture antenna. So, all antenna is aperture antenna. I take a quiz, huh? In quiz there will be a question. On antenna is of which type? Aperture, microstrip or wire? So, on is aperture antenna. What is aperture meaning? Aperture means some kind of opening through which electromagnetic waves radiated or received. Do you see some kind of opening? So the first picture, the top picture is called rectangular waveguide. It is like a pipe, rectangular pipe. You have a cylindrical pipe in your house to carry water from source to different places. So you can see exactly a pipe, but what is the configuration of the pipe? Rectangular. So this is called rectangular waveguide. Below rectangular waveguide, there are two horn antennas. On your left side, it is called pyramidal horn antenna. On your right hand side, it is called conical or cylindrical horn antenna. Now for each type, there is mathematical analysis possible. There are several configurations possible. Several electromagnetic modes travel through these kind of antennas, which we can analyze mathematically. How can we analyze? With the help of 4 mathematical equations given by a scientist called Maxwell. Have you heard his name, Maxwell? Maxwell. So, Maxwell is considered a person who gave the theory of electromagnetic waves. For the first time, 1864, remember, 1864, Maxwell presented several mathematical equations and theoretically he proved the existence of EM waves. Now you should ask me a question. What is the importance of EM waves? Do you see EM waves? Do you see EM waves? They are present here. Are they present here? All mobile waves that you see. Okay? Right now also, if you are getting a mobile phone, maybe your mother has called and your phone is on vibrating mode, silent mode, so others are not able to listen. But if it is on vibrating mode in your pocket, you can feel. So this is because of electromagnetic waves traveling through free space, or what we call wireless communication. So for the first time in 1864, Maxwell, with the help of 4 mathematical equations, proved that there are EM waves. So at that time, initially when he presented, people could not believe. Why? There was no experimental proof. There was no verification. He only presented 4 equations. I don't know how many of you remember. Have you come across these 4 equations? I'll tell you these 4 equations. Now, very simple. Professor Guha said, electromagnetics, antenna, microwave. They are very, very simple. I fully agree with you. You have to deal with only E and H. Only 2 E and H. And only 4 expressions given by Maxwell. Now I tell you first expression. Del dot D is equal to rho E. That is basically Gauss's law. Second expression. Anyone can give me second expression, easier one. Del dot P is equal to 0. What do we call physically? Physically, non-existent existence of magnetic monopole. I tell you why. What did I say? Del dot P. What is del? Del is a mathematical operator. Have you come across this expression? Del dot P is equal to 0. Yes or no? These days, these equations are being taught in very science also to the best of my knowledge. Del dot P is 0. Is called non-existence of magnetic monopole. I'll give you simple example. When you were kid, maybe in 5th standard, if your mother has given you a magnet, have you seen magnet? So magnet has got 2 poles, north pole and south pole. Can you separate them? Can you separate them? If you have a magnet, experiment. Let's do it. Can you separate north pole from south pole? No. Divorce not possible between north pole and south pole. They are always together. What is this? They are 2 in number. What Maxwell said? Non-existence of magnetic monopole. Mono means 1. Single. So he said single pole not possible. And that exactly your statement. In a magnet, there are always 2 poles, north pole and south pole. If you try to divide them, can you divide them? No, always remember, you have experimented, you have verified in your school days, north pole and south pole cannot be separated. That exactly Maxwell said. And that is why Professor Guha and I say that antenna is the most simplest tool. Very simple. And without antenna, you cannot survive. That is why we need to study antennas. If you are interested in wireless communication, radar, satellite communication, Wi-Fi, Bluetooth, you need to study antennas seriously. Okay, so I talked about 2 equations. Do you remember? The first one is del dot T is rho v. Second expression, del dot P is 0. Third equation, del cross E is equal to del cross E is equal to minus del E by del T. Okay, that is basically Faraday's law. Did you study Faraday's law? Faraday's law. So that is Faraday's. The fourth equation, who gave Ampere gave actual expression was given by Ampere. It is called Ampere's capital law. Del cross H is equal to minus del E by del T. And now comes contribution of Maxwell. You know, people say that Maxwell has not done anything. He has just collected 4 expressions. Which are those 4 expressions? Then the T is equal to OV, then dot P is 0, then cross E, then cross H. But actual contribution of Maxwell is he studied Ampere's capital law. And he corrected Ampere's capital law. He added a term which again Professor Guha used in his lecture. You know what is that term? Displacement current. As an ECE engineer, know what is displacement current. So that is one contribution of Maxwell that he corrected Ampere's circuital law. You may think, sir, just one correction, and he became so famous. Then one correction suggested by Maxwell. What is the correction? Addition of displacement current in the 4th expression. That actually became what you see wireless communication today, electromagnetic theory that we study today. So that is why Maxwell is considered as father of electromagnetic waves, or what we call a person gave theory of electromagnetic waves. Maybe last few minutes before I close, these are different types of reflector antennas. The first one is a parabolic reflector antenna. generally for space applications, radar applications, we use parabolic reflector antennas. The second one that you will see looks like the corner. You can see. So that is the corner. The third type is a plane antenna. So there are three basic type of reflectors. What did I say? Three basic types of reflectors: parabolic reflector, corner reflector, and plane reflector. Again, parabola. There are seven types: front fade parabolic reflector, offset fade parabolic reflector, dual reflector. Again, in dual there are two types: Cassandrian dual reflector, Gregorian dual reflector. Okay, so these are different configurations. Later on, the way you progress towards your higher semesters or maybe for your master's degree, you may take these topics for your research or dissertation. Microstrip antenna, very simple. They are called planar antennas, printed antennas. I will recommend all of you, everybody. I did this in my college also. Every BTech 6 semester student, we gave them application and asked to design and fabricate microstrip antenna that you can do here in your laboratories. You will enjoy doing this exercise. I will request all current professors in this exercise: designing, simulating, fabricating simple microstrip antenna. Okay, in your body. These are array antennas. Now you can see here similar type of antennas are put in a particular fashion. You can see the bottom one, extreme of left, bottom. These are called array of microstrip antennas. Do you see black rectangular? So many black rectangulars, they are patch antennas put in 2D fashion, 2 dimension, a few rows and a few columns. So that makes 2-dimensional array. So array can be 1-dimensional, 2-dimensional, or 3-dimensional. Okay, are you ready? Now very soon I will take quiz. So whatever I have discussed, you will have to answer. Fine? Otherwise, we will not get certificate. Or you got certificate. Okay, fine. These are different lengths antennas. This is family of antennas. First generation antennas, second generation, third generation, fourth generation. So these days, we teach our students some modern antennas like active integrated antennas. We teach them reconfigurable antennas, smart antennas. They are latest like dielectric resonator antennas. So these are all new antennas, but conventional are more wire, reflector, etc. So, friends, last 5 minutes, I would like to ask questions. Everybody has to participate, correct? This is a quiz round. I want to understand how much did you learn from the entire day. Everybody, ready? Do you want to become successful in life? Yes. If you want to become successful, you will have to participate. You will have to answer. You will have to express. Okay? Ready? Wonderful. First question. Very simple question. What is antenna? Only one. Only one. Come on. Yeah. You. Antenna is a sensor. Very good. Very good. Okay. Who will give me name of at least 5 different antennas? Anyone? Please raise your hand. 5 different antennas from boys. You? 5 different antenna types. Come on. 5 names. Just one. Anyone just. Name. Huh? Enough. Huh? Antenna type. Name of. I think some one name? Huh? Reflector antenna. Very good. Very good. Wire antenna. Okay. Okay. Okay, what is the contribution of Maxwell? Maxwell, what did he do? What did he do? Did he apply some connection? Yes, sir. Yes, who said this? Very good. So he directed Ampere's second law. So he added one term that is called displacement current. Very good. Very good. Fine. What is the contribution of Sir Jagdish Chandra Bose from India? Which type of antenna Professor Kumar showed in his last few slides? Huh? Dipole and one more, for which he got patent. Horn antenna. Very good. Very good. In your mobile, do we use reflector, horn, dipole, or printed antenna? Very bright. I'm really impressed by all the students of this particular college. Very good, very good. We use high frequency to get what kind of benefit? Any one benefit, if you use high frequency, gigahertz frequency, your antenna becomes smaller or bigger? Smaller. Very good. You will decide the configuration of antenna based on what? If you are asked to design an antenna, what will you ask to your boss? Application. Very good. Very good. So depending upon application. Okay. Can you give me one or two applications of wireless communication? Wi-Fi is so many. Fine. Okay. Professor Guha showed you a very nice history of wireless antenna. Can you name two scientists? Two scientists. Names of two scientists. He shows several names. As an EC engineer, you should know. एक तो symbol हम use करते हैं, unit हम use करते हैं, frequency का unit. We use yes, inch, hertz, Marconi, ampere, Gauss, and Jagdish Chandra Bose sir, and Maxwell. Okay? Very wonderful. Now, if you want to design an antenna, last question. Which parameter you should consider? Very important parameter of an antenna that you consider. Huh? Frequency. Very good. What is? What? Gain of antenna. Very good. What said? Gain of antenna. So, gain of an antenna. Then there are other parameters called bandwidth of an antenna, beamwidth of an antenna. Beamwidths are of two types: half power beamwidth, first null beamwidth. Okay. एक और last. आप last. Can you give me names of two different reflectors? Parabola and plane reflector and corner. Wonderful friends. So happy to be here this afternoon. I'm so thankful to the organizers, your chairmaster, the principal, and our mentor, Dr. Guha, and my friend, our mentor, Dr. Ram, and my friend, Dr. Guha, for inviting me here for this wonderful talk. You are really amazing. God bless you. Make your mobile number become your parents. Thank you so much.